Professor Ayhan Erdem, Head of the Department of Gazi University Technology Fakültesi, Department of Computer Engineering. Today, I will present to you about my work related to one of the hot topics in the world of technology, GPT models for irony detection. And during my presentation, I will first briefly talk about the irony, then GPT and its models. Afterwards, I will talk about the dataset and evaluation metrics, then how models are used in the study. Later, various GPT models will be compared within itself and with state-of-the-art of models in irony detection and classification task. Finally, I will conclude my presentation by talking about the advantages and disadvantages and GPT models, or the state-of-the-art models make suggestions to achieve. Today's subject table of contents, irony and its challenges, overview of GPT, dataset evaluation metrics, methodology, comparison of the model, conclusion. Irony and its challenges. What is irony? Irony is the use of words of the expression opposite of literal meaning. In irony, the word spoken aims to draw the opposing statement of the point of contradiction. There are several different types of irony, and the most common are verbal and situational irony. It is very common in our daily lives. For this reason, it is also a very important issue in human-machine interaction. Irony indirectly underlines what is intended to be said through facial expression, gestures, and word emphasis. Today, since human-machine interaction is mostly limited to text, these auditory and visual supports cannot be transmitted to the machine. For this reason, machines' detection and classification of ironies remains challenging in natural language. Overview of GPT. GPT is an abbreviation for Generative Pre-trained Transformer. Transformer is a mechanism which first introduced in the paper Attention is All You Need by Vesvani et al. In 2017. It is a type of natural networks architecture that utilizes self-attention mechanism, allowing for effective processing of sequential data and achieving remarkable performance in various natural language processing tasks. GPT is transformer-based pre-trained language model developed by OpenAI. The first GPT model, GPT-1, was released in 2018 and has 120 million parameters. It is trained with 4.5 gigabyte data. GPT-2 published in 2019 preserves is an architectural structure, but the number of parameters reaches 1.5 billion. In the training, 40 gigabytes of text was used with the GPT-3, announced in the 2020. The models has made a huge leap forward. Although the number of parameters varies in different models, it has reached up to 175 billion and has been trained with 570 gigabytes of data from many different sources. The GPT-3 model, which continued to be developed, have been replaced by the GPT 3.5 models and the GPT-4 models. Dataset and evaluation metric. Semantic Evaluation 2018 Task 3 dataset is designed for irony detection and classification in the English language. This dataset is compiled from Twitter messages written by various individuals at different times on the social media platform Twitter. The dataset pre-printed in two different forms. The subtext A is a binary dataset used for irony detection. Subtext B is a multi-class dataset. It contains verbal irony, situational irony, other irony, and non-irony classes, as suggested in the original dataset paper. The evaluation metric used in the work are accuracy, precision, recall, and F-peer score, while accuracy gives an overall view of the system's performance across all classes. The remaining three metrics were spatially computed for the positive class in irony detection task and were macro averaged across four class irony classification task. Methodology. This study consists of two parts. In the first part, the success of the GPT models, namely Text DaVinci 003 and GPT 3.5 Turbo in irony detection and classification task, was evaluated in both zero-shot learning and few-shot learning methods. In the second part, what embedding models used by the GPT models, namely text and embedding Babbage 001 and text embedding Ada 002 are compared with the GLOW word embedding model GLOW 0.6b 100D using various machine learning methods. All the results obtained were compared with the terms themselves. The best results obtained were compared with the result of previous studies. How GPT model works? In complete GPT models, the models expect the user to define the task to be performed on the give examples, if necessary, depending on the learning method. In this way, it is aimed to first understand the task is needed to do and then increase its success in the task is it will do through example. If provided here, you are seeing the format of text which is given the models. When the few-shot learning method was applied, the sample provided the model were randomly selected from the training set of the data set. The number has been determined as 42. The example provided to the model in the few-shot learning method are the same in irony detection and classification tasks. While there are 21 ironic and 21 non-ironic examples in the detection task, there are 21 examples of non-ironic, 16 verbal irony, 3 situational irony, and 2 others irony in the classification task. The embedding model, some processing setting also employed in the text like tokenization or cleaning of spatial patterns found in tweets and custom changes like addition of arrow or cleaning of stop words and punctuation. The best result obtained by the Text DaVinci 001 and GPT 3.5 Turbo models are shown in Table 1 for irony detection and Table 2 for irony classification. In detection task, DaVinci 003 model obtained better result with few-shot learning method, while GPT 3.5 Turbo achieved better in zero-shot learning method. In classification task, both models achieved better result with few-shot learning method. In second part of the study, two of GPT text embedding models, namely text embedding Babbage 001, text embedding Ada 002 models were compared among themselves and with the GLOW 0.6b.100D model, which is one of the GLOW embedding models using various. The purpose of the show at the right side of the slide. Static learning library is used for RF, KNN-DT, GMB, Ada, BOST, and MLP algorithms. The parameters have been kept at their default values and non-fine tuning has been made in CNN, LSTM, and GRU models that give better results with various parameters were sought processing methods employed as well. Results. The best result obtained by each model for each learning algorithm are shown in Table 3 for irony detection and Table 4 for irony classification. CNN, LSTM, and GRU models, when used in natural language processing, task classify each word based on the relationship it established with the surrounding words. These models work well when GLOW text embedding is used, as each word is represented by a vector of certain length. However, when text embedding Babbage 001 and text embedding Ada 002 text embedding are used, only one vector is formed for the entire sentence. So the effects of words on each other cannot be adequately understood by the model. Therefore, consistent and successful result cannot be obtained, thus no result could be entered, apart from CNN, LSTM, and GRU algorithms. GLOW text embedding model was only able to achieve a more successful F1 score in the DT algorithm of the binary classification task. Moreover, in any model where GLOW text embedding is used, it didn't achieve better results than text embedding Babbage 001 and text embedding Ada 002 models. The most successful model in irony detection task is an LP model, which using the text embedding Ada 002 model. On the other hand, the most successful model in the irony classification task in the GMB model, which uses the text embedding Ada. These tables show the best results obtained in irony detection and irony classification task in each specific category. The best result in irony detection task is obtained from text DaVinci 003 model with 68.9 FP score, and the best result achieved irony classification is the F1 value of 48.5% obtained by the Gaussian naive-Bayes classifiers using the GPT text embedding model text embedding. When they compare this result with previous studies with same dataset, we see that both in irony detection and irony classification, the models obtained comparable results. In irony detection, text-Da-Vinci 003 model has the best recall value, also in F1 score, very close to above models. In irony classification task, which is the obviously more difficult for all the models, GMB with the embedding, ADA 002 model has obtained the fourth best F1 score. Considering that the architecture of this model has not changed at all, we see that only two models are more successful than the text-Da-Vinci 003 model in both irony detection and classification tasks together. The biggest advantages of complete GPT models, namely text-Da-Vinci 003 and GPT 3.5 turbo models, is that instead of using customized model for each task, it provides the opportunity to get results almost as good as the customized models without needing a dataset alone. Even in few-shot learning method, a few samples are sufficient for the model. The biggest disadvantage these models have is their high cost. To achieve better results in complete GPT models, studies can be done to say the same thing in the different ways. In the second part of the study, the success of the GPT text embedding models, namely text embedding ADA 002 and text embedding Babbage 001, were compared with GLOW, which is one of the best text embedding models. We saw that these models achieved better results when we compared them with different algorithms. Since the aim of the second part of the study was to compare text embedding models, no hyperparameter settings were made. For this reason, GPT text embedding models can be used with more appropriate classification algorithms and with hyperparameter adjustment can achieve better results than state-of-the-art.